Hey everybody, today we're going to be covering the first section out of many. This section is Chapter 1, Section 1, Solving Equations, and it's on page 4 in your book. I don't think you'll have a problem with this one. We're starting off nice and easy. You should be able to solve these equations in one step and using some simple addition, subtraction, multiplication, and division. The first thing that we need to know, however, or refresh, is that addition and subtraction are inverse operations. Multiplication and division are inverse operations. Don't get scared or nervous about that fancy word inverse. All that means is opposite. So you can say inverse, you can say opposite, doesn't matter. It means the same thing. We're going to be using inverse operations to solve this equation, and we know that this is an equation because there's an equal sign in the middle of it, right here. And this is actually example 1, letter A. It says x minus 7 equals negative 6. Recall that in order to solve an equation, your whole objective is to get this variable, the variable x, on its own side of the equal sign and all the numbers on the other side. In order to do that, we're going to have to move this negative 7 over to the other side. The way that we do that is we have to use the inverse operation. And so we look at the inverse operation. We look what operation they have right there. They have a minus 7. Going back up to the top where our little notes are, you'll see that we have the inverse operation of subtraction is addition. So to get rid of this negative 7, we are going to have to add 7 to both sides to keep it equal. So we're going to add 7 to this side, and then we're going to add 7 to this side. Whenever you do inverse operations, you must do it to both sides of that equal sign. Don't forget, it's kind of like a balancing act. Okay, you got to keep both sides balanced. Okay, on our left side of the equation, a negative 7 plus 7 just cancels out to give us a 0. And so all we're left with is x. On the other side, however, we have a negative 6, and we add 7 to that. Well, when you do that, negative 6 plus 7, you're going to get 1. So to solve this, the solution to this equation is x equals 1. This is example B in your book on page number 4. Y plus 3.4 equals 0.5. We're going to attack this one the same way we attacked the last one. In order to solve and get y all by itself on its side of the equal sign, we need to use the inverse operation of addition. We see the addition sign right here. We could go back and check, but I already know that the inverse operation of addition is subtraction. So I need to subtract 3.4 from this side to get it to equal 0. And if I do it on one side, I need to subtract 3.4 from this side. Well, on the left side, I get 3.4 minus 3.4. That's going to cancel out, and it leaves me with a y. And on the right side of the equation, I get 0.5 minus 3.4, and that'll work out to a negative 2.9. And now we've used inverse operations to solve that equation as well. Alright, here's a nifty little trick. This is the problem from the last slide, y plus 3.4 equals 0.5. We solved for that on the last slide, and we found that y has to equal a negative 2.9 in order for this equation to be true. You should never get one of these wrong because you can always check your work. All you have to do is once you solve for y, plug it back in for y into the original equation. So plug negative 2.9 back up here for y, add it to 3.4, and see if you get 0.5. Okay, so the simple way to do this is I'm going to take 3.4, I'm going to subtract 2.9, and if I'm correct, if we solve this right, we should get 0.5. Okay, sorry about that messed up arrow there, can't draw with my finger. So let's try this out. 3.4 minus 2.9. I can't do 4 minus 9, so I'm going to borrow from the 3. Okay, carry over, make this a 14 minus 9. That gives me 5. Bring down your decimal. That should be a 2 since I borrowed. 2 minus 2 is 0, and what do you know? I got 0.5. So indeed I know that my answer of negative 2.9 is correct. If you take the time to plug in what you got for your variable back into the original problem, you'll get every single question right. Moving on to some with symbols here. Here we have h plus 2 pi equals 3 pi. This is example C under example 1. We're doing the same exact thing. All we're trying to do is we're trying to get h all by itself. And in order to do that, we have to use the inverse operation. I look and I see that I have an addition sign there, so that means I'm going to be subtracting using the opposite of addition. So the opposite of plus 2 pi is going to be minus 2 pi. Okay? And whenever you do it to one side, you're going to hear me say this over and over, you have to do it to the other side. So you're going to subtract 2 pi. Okay? Well, if h has 2 pi's and then he eats 2 pi's, he doesn't have any left over. And he's left lonely with no pi's. On the other side of the equal sign, you have 3 pi. And you take away 2 pi. That leaves you with 1 pi. Or you could simply write it as pi. Same thing, although the more accepted way to write it is just pi. So your answer should be h equals pi. Not too bad, right? I didn't think so. Should be pretty easy. A nice way to start off the year. Here we have, this is the on your own example 1. And the way that we're going to do this is, I'm going to put a few of these on your owns on here. What I want you to do is I want you to pause the video. I want you to get a scrap piece of paper or your notes out. I want you to try to work it out on your own. And then once you think you have the answer, you're going to unpause the video, keep going, and then I'll work it out with you, and you will see if you got the right answer. So we can check your work as we go here. Okay, so this is on your own number 1. B plus 2 equals a negative 5. So at this time, I would like you to stop the video, pause it, work out the question on a sheet of paper, and then unpause it when you're finished, and we'll see if you got it right. Alright, hopefully you got it right. Let's see what you did here. We have b plus 2 equals a negative 5. What you're going to do is you're going to subtract 2 from each side using the inverse operation. Okay? So remember, if you're going to subtract 2 from each side, you need to subtract 2 from both sides. 2 minus 2 leaves you with 0. That cancels out, and all you're left with is b on the left side. On the right side over here, we have a negative 5, and then you take away 2 more. So be careful when you're dealing with integers, especially negative integers. You have negative 5, and you're taking 2 more away. Okay? So if you need to draw out counters, you can draw out counters. You could do 5 negative symbols. 1, 2, 3, 4, 5. Those are bad negative symbols, but it's just a rough picture. And then I have 2 more negative symbols. How many negatives do I have in all? Well, you should get a negative 7. Okay? So your answer for number 1 should be B equals a negative 7. careful because you might have got -3 or 3. All those are going to be wrong. It needs to be -7. If you're unsure, remember, go back, plug it back in to the original equation. You could have checked yourself. If you got it wrong, for b you could do -7 plus 2 equals a -5. You would find that to be true. -7, and then you add 2, you're only going to be at -5. So you would know that you were correct at that point. This one here, this one is number 5, and I chose it because it has fractions, and a lot of times we get scared of fractions and freeze up. But they're just numbers, and we'll learn how to deal with these. First thing, we're just going to do the same thing like we always got to do. We're going to use the inverse operation. I see that my operation is a negative, and so the inverse of that is going to be positive. And so I'm going to do plus 1/4 on this side. Whatever I do to one side, I have to, hopefully you said do to the other, because you're right. Okay. Ooh, that's ugly. Let me redo that for you. It is hard to draw numbers with your finger on an iPad. There we go. Okay, so we have t minus 1/4 equals a -3/4, and in order to do that, I need to add 1/4 to both sides. When I do that, this cancels out, and I'm left with just t. Okay. On the other side, remember that stinky little rule. Whenever you are adding fractions, you have to have the same denominator. It just so happens in this case, I do. I have a 4 here and a 4 here. So, I'm good to go. I'm going to add the numerators first. A -3 plus 1 is going to make me end up with a -2. Keep the same denominator, and that's going to be a 4, right? -2 over 4 can be simplified down to a -1/2. So that would be our answer for on your own, number 5. Alright, on this one we're going to start example number 2, dealing with multiplication and division. We have to remember that multiplication and division are inverse operations of each other. So obviously we don't see any positive addition or subtraction signs here. That is a subtraction sign, but it's really just a negative, and over here it's a negative as well. Okay, so we're going to be using multiplication and division, and in this problem it's saying a -3/4 multiplied by n is going to be equal to a -2. So I'm going to have to get the n all by itself. In order to do that, since it's being multiplied by -3/4, I'm going to have to divide it. Okay? So there's a rule that we need to remember, and I'm going to write a new line. I'm going to write it in red. Okay? Whenever you divide by a fraction, okay, whenever we have to divide by a fraction, the rule is that we're going to flip the fraction upside down, okay, and then we're going to multiply it, okay. So I flipped it upside down, and we're going to multiply, and we have to do it to both sides. Okay? On the left side of this, it's going to cancel out. Okay? The 3 is going to go with the 3, the 4 is going to go off with the 4, and we'll be left with just n. On the other side, over on the right side, we have a -2, and it's being multiplied by -4 over 3. The way to attack this is you give 2 its own denominator friend, and then you're going to have to multiply across the top, and then multiply across the bottom. Okay, so let's do the top first. We have a -2, And we need to multiply that by a negative 4. When you do that, a negative 2 times a negative 4, think back to your rules. Negative times a negative is a positive, and 4 times 2 is 8. Then on the bottom, just multiply across. We have 1 times 3. 1 times 3 gives me 3. So I write a 3 on the bottom. And so my answer is n equals 8/3. Alright, on this one, we have pi times x equals 3 times pi. This is letter B under example 2 in your book on page 5. Okay, same goal. We're trying to isolate x all by itself on its own side of the equal sign. And so what we need to do is we need to get rid of that pi. And since it's being multiplied x times pi, we're going to do the inverse. And the inverse is going to be dividing by pi. Okay? Whatever you do to one side, we have to do to the other. Nice job. Okay, on the left side, I'm going to do that first. You have a pi divided by pi, and that cancels out. Okay? Just becomes 1, leaving us with x. On the right side, we have 3 pi divided by pi. In other words, how many times does pi go into 3 pi? And your answer is 3. The pi's cancel each other out, and it leaves you with 3. So our answer is x equals 3. Now if you think about it, that makes sense, because if we replace x back into our original problem with 3, we'd get 3 pi equals 3 pi. Not too bad, right? Alright, let's look at the on your own problem number 7. This one I want you to try on your own. You're going to start with y over 4 is equal to a negative 7. Okay? Pause the video and see if you can solve this one on your own real quick. Alright, had you done this correctly, you should have seen that it is division in this problem. Your y divided by 4, so the inverse of that is going to be multiplication. So I need to multiply by 4 on both sides. I'm going to multiply this side by 4, and I'm going to multiply this side by 4. On the left side, those 4's cancel out, and I'm left with y. On the other side, I have a negative 7 times 4. So remember your rules, a negative times a positive, and that's always going to be a negative. And then 7 times 4 is simply 28. So your answer for number 7 on page 5 is going to be y equals a negative 28. Alrighty, last one probably for this video at least. This is number 8. They have 6 pi equals pi times x. Okay, pause the video. Use your opposite operations, your inverse operations, to see if you can figure out what x is supposed to equal. Okay, your whole goal is to isolate x on its own side, and I see that it's being multiplied to pi. So I am going to do the inverse operation and divide this side by pi. Divide this side by pi. On the right side it cancels out, and it leaves me with just x. On the left side the pi's cancel out and leave me with just 6. So I get 6 equals x. I'm going to rewrite that so the variable comes first. X equals 6. And then I'm done. Hopefully you got that answer correct as well. Overall, not a bad way to begin the book. This should be review for most of you. Hopefully it made sense. Feel free to ask questions, email me, ask in class. But that's it. That wraps it up, our first lesson. We'll talk to y'all again.